Okay, we're picking up on this slide. I think it's about slide 30, and this is video 2 for air pollution unit. Again, we're in chapters 18 and 19 for this unit. Okay, so we talked about precipitation in the last slide. Just remembering the different types of precipitation are all based on size and the temperature. And then the other effects, other stuff that would affect precipitation is the winds and the mountain ranges. Would cause or increase or decrease precipitation. So winds, wind is moving from high to low pressure, and then vertical again is the opposite, from low to high pressure. So horizontal is what we're most aware of, most common, and then the vertical is the opposite to that. The speed is determined by how different the pressure is, how steep that gradient is. And then that Coriolis effect that I talked about comes back to, or one of the causes from that. And the Coriolis, I kind of skimmed over it, but it's the look at the gravitational pull from the moon and the way the Earth is rotating, taking into account the tilt of the Earth, the 23-degree tilt of the Earth, stuff like that. And all of that causes, this whole chain of events and effects from that Coriolis effect. So it causes winds that to spiral rather than just moving straight into low pressure zones. It's detected. We use an anemometer for wind speed. We use a weather vane to look at direction, and it's based on where it's coming from. So wind from the east is an easterly. The Beaufort wind speed scale is the range 0 to 12 to tell you how much the wind is moving. And that has us, like people talk about hurricane winds, that would be a 12 on the Beaufort scale. Okay, looking at high pressure, these are all the wind patterns, global wind patterns. Again, you guys looked at this a little bit when you did your climate map, but that looks at the trade winds and then the westerlies. Those are the big wind patterns that we see. This is circulation patterns that we see. Fronts. A warm front separates warm air from cooler air. It rises over cool air masses. We know heat rises, so that makes sense. And it usually causes and develops clouds and light rain. A cold front is cold air advancing into warm, and it pushes under the warm air. And that's strong vertical movement, and so that's stronger weather. That's where we're going to get thunderstorms and stuff. So a lot of times, you'll see the temperature drop with that cold front coming in, and you see the rain coming in. We just had the cold front the past 2 days. You guys are going to be watching this next week. So last week we had the cold front come in, where you see that temperature dropping. You see that temperature dropping and the vertical movement going. Severe weather, if we're looking specifically at thunderstorms, occur primarily in tropical, subtropical, and temperate zones. We don't see them as much in the polar and subpolar zones. Depending on what climate you're in, you're going to see hail or rain. You will definitely see the strong wind pattern. You'll see lightning. You'll see thunder. And again, depending on climate and location, you'll see those tornadoes from that wind pattern. The moist air is going to rise to the front, which is a loss of heat. And then at that height, that 42,000 feet, that's where you get the downdrafts and precipitation. So it's a fight. A thunderstorm is a fight between the warm air rising and the cold air dropping, and that's what causes thunder and lightning. That's the change. Lasts for about an hour. Severe ones occur when the cold front is hitting that warm front, which supplies more moisture and energy, and that's where you get the more crazy wind, hail, as opposed to just thunder and rain. Tornadoes, 300 plus miles per hour winds or airspeed, wind speed, same thing. Water spouts, if you're over water, lake or river or ocean, they're caused by extreme low pressure, which actually can implode a building. The destruction is usually less than a half a mile wide, 15 miles long, so they're very narrow paths. You can see, and you've all heard and seen, because we live in a tornado or close to tornado zones, where they'll hit one house and then the houses all around it are totally fine. From Texas to Indiana is where we usually see them, made famous by the Wizard of Oz. Hurricanes. Hurricanes are one of the more dangerous storm patterns. A lot of property damage, loss of life. There have to be wind speeds greater than 74 miles per hour at the center. They begin over the ocean. That's where they get all their energies build up from that ocean temperature fronts from solar insolation. So the sun is essentially heating up the water greater than 80 degrees Fahrenheit, and that provides that energy. There's this huge evaporation pattern, and then from that evaporation now we have a whole bunch of water in the air, which means that there's clouds forming, the atmosphere is lifting and moving, the fronts are moving, and that's what causes that hurricane, and then that energy just moves. There's stages to a hurricane, and we separate that. There's a cyclonic circulation, which causes them to pick up more moisture and heat from the ocean. So you're looking at the slower ones, the smaller ones are tropical depressions. That's wind speeds of 23 to 40 miles an hour. And then you move up to a tropical storm at 40 to 75 miles an hour. And then over 75 is an actual hurricane, and there's a gradient between the hurricanes. The center of the hurricane is called the eye of the hurricane. And you have excessive rainfall, 24 inches in 24 hours, which is ridiculous amounts of rainfall. So this is kind of just looking at some of those weather patterns. It's really an ooh pretty type thing. I am definitely not a meteorologist. Once you see the thunderstorms coming in, you can see the fronts pushing up, the cold front pushing down. You can see the cyclic pattern that we were talking about. You see all the excess energy gathered up here into this thunderstorm. Really pretty colors. You know, a lot of times you get that absorption and scattering of the light in the ozone, and that causes some really unusual colors when it hits all that water vapor, all the precipitation in the air. Tornado formation, you see again that cyclic formation. Okay, so now we're moving into El Nino and La Nina. So the El Nino, Southern Oscillation, which we're going to go with ENSO, happens every few years, and it happens when the westerly winds weaken or stop, and the surface waters get warmer. That pushes upwelling. That suppresses, had it backwards, that suppresses upwelling, which leads to declines in fish populations. So essentially it's an oceanic condition. So this, you see the normal conditions where you have stuff moving around, convective loop, keeping everything going, and you have upwelling happening where it's supposed to happen, and then in El Nino you see the increased convection, and you miss that upwelling. It's a weakening. It's caused by a weakening of the atmospheric and oceanic circulation. Stuff is forcing that off balance. So again, this is, look through these diagrams, make sure you understand a normal versus an El Nino event. What's the difference between those two things? You see the difference in upwelling, you see the difference in the winds, difference in the rainfall, and the pressure systems. Look at all those and summarize that. The connections throughout cause effects throughout the globe. For example, it creates warm winters in Alaska, lots of rain in California. It's unusual weather patterns. El Nino creates unusual weather patterns for that area. La Nina is the opposite. And this is when the winds are blowing across the Pacific are stronger. So in El Nino, we saw the winds were weaker for whatever reason. Now we're seeing the winds are stronger. And that means that the warm water accumulates, and the water near Peru is colder, which causes droughts and excess rainfall. So it really totally depends on your location as to what effects you are seeing. Okay, climate, we've talked about already. We know what it is. It's the weather, temperature, and precipitation. Those are the two big factors of climate. Climate can have seasonal variations, and there are weather extremes, outliers that we don't take into account, so it's averaged over a long period to get you the overall climate for a specific location. So the stuff that affects the temperature in the climate is the latitude and the elevation. That makes sense, right? The more the higher up, the colder it is, the bigger you'll have, go from mist to sleet to hail, or to snow to hail. You see different types of precipitation, different types of temperature. And then it's the closeness to large bodies of water. Water, again, acts as that heat source. You have that high carrying capacity for water. So the closer you are to a large body of water, the less you see in temperature changes in temperature range, right? If it's super hot out, you want to go down to the beach, because not only can you get in the water to cool off, but it's not quite as hot at the beach because that water is acting as that heat sink. Okay. We've talked about this already when we were talking about biomes. You see the differences between plant life based on elevation and temperature. I just talked about this. This makes sense. So if you compare the internal away from the water temperature to the external temperature, you see much more mild. Okay. The short-term changes in climate result from ocean current change, wind change, very basic stuff that is very hit or miss. Currents help transfer heat to the atmosphere, and that generates global winds. So the global winds help move the ocean current. So you see the very cyclic nature of all this stuff. Any major change in an ocean current can cause a change in climate. So El Nino is an example of that. This is why we're so worried about the ice melting, because that throws off the temperature, which throws off the ocean currents, which just gets everything crazy and